Let me back up just a little. So in all the networks we talk about today, so we're in the next generation network today. When we started this company in 1994, our CEO, Dave Hirschberg, and a group of us all agreed that in the very near future, all transport of information would be done in IP format. And not long after, and we built this company around that premise. Not long after that, the concept of the next generation network was brewed up in the ITU and in 3GPP. And all of these networks are simplified networks conceptually. There's only two layers, the application layer and the transport layer. And there's a concept of this pure packet transport layer, the IP cloud, that will handle any application. The problem is that it's not engineered to handle even one of those applications. The engineering that goes into handling those applications is done on a case-by-case basis. When cases are very common, the solution becomes very commonly known and everybody can do it. When cases are less common, the solution is not well known and you got to be embedded in the industry to understand how to deal with that problem. So a lot of the networks that we deal with are operating with a little bit of satellite, going back to the previous question. And when there's a little bit of satellite, the way that the network has to be used, the way the protocols have to come together becomes quite complicated, and it just takes a lot of experience to put that together. Now, the network, the concept is there. Everybody's working to make the network ubiquitous, to make one IP cloud handle any application. So as we go on in time, we get closer and closer to that point that we can handle it, but even when we handle it, we don't necessarily handle it efficiently. The first step in this process is to handle it, to make this application flow. But it may flow very inefficiently. And by inefficiently, what we see in the world is a network using 5 times the bandwidth it needs to use, not 20% more bandwidth. And the reason being is that the protocols were not set up to transport this IP cloud with a little bit of satellite in it. And quite often, anytime you concatenate multiple networks, a lot of terrestrial wireless networks cause the same problem. The protocol stacks were not organized in a way to be efficient. Simple example, if I have packets in my transport mechanism that have 53 information bits, and I hand it 27, I'm going to waste 26. The IP protocol doesn't care. It's got a packet, it's loaded, it's got an overhead, it goes where it's going, but we just wasted a lot of bits. So we need to shape that application to feed what's available. In any there's a term now used, session initiation protocol, probably a good example. Voice, in the early days of when we talked about IP voice, the first IP voice programs we did at GSI, there was no effective way to move voice over an IP network. People used to say, oh, it had bad quality and everything else. Well, the reason it had bad quality is the packet structures were not well organized to handle voice. We actually patented structures like that in some of our earlier programs. Those patents are no longer necessary because standard protocols were invented, H323 and then SIP, Session Initiation Protocol. Session Initiation Protocol, very interesting, very easy to understand because in a pure packet network, I take information, I put it in a packet, and I put an address around it and some other information around it, and I send it to you. And then I get some more information, I put it in an envelope, and I send it to you, this envelope being the packet structure. In a telephone call, I know that every packet I'm going to send is going to you. So we establish in IP terminology a session, which in legacy terminology would be a call. I eliminate all the unnecessary bits in the overhead, and I structure my packets to fit what's coming out of my voice application. So if I've got 23 or 53 bits, which is a common, or 53 bits of voice information coming in a very, very small packet with small overhead because I don't need the overhead, I put 53 information bits in the transport packet structure. So very easy to ignore that. And again, the satellite link is so unique and so open. There's a million ways to do any satellite link, and there's no one standard way of doing it, and that's all left up for the engineer to resolve and make it efficient.